In the first supplemental video of this lesson, I showed you how you can print the contents of memory in binary, although the program we wrote ended up being quite a bit longer than it needed to be. So now that we've learned a bit more about loops, I'm going to show you how to make this program much simpler and much smaller. So let's start out with our basic program here. We're going to create a character, we'll call it myChar and set it to A. Now, if you remember, the way that we did this is we created an if statement and we used the AND operation in order to test a certain bit. So what we basically did is we said that if myChar and then we wrote in binary what we wanted the value to be. So if we were testing the first bit, we did like so, and we could say printf 1, and then we wrote a whole different if statement here for if it was equal to 0, in which case we printed 0, and this took care of bit 1. Now, of course, since the character A is in binary then we know that the first character is in fact going to be a 0. If we run this program in its current form, you'll see that we get a 0. Now we can repeat that process for all of the different bits and basically copy and paste this code, but there's a much better way to do this. So there are two things that I want to show you here. The first is, whenever you have two if statements that are opposites of each other, you can join them together into a single if statement using the else keyword. The else keyword has the effect of saying that if this is true, evaluate this, otherwise evaluate this. So here we're saying that if the bit mask and the character results in a non-zero value, then we want to print a 1. Well, otherwise we obviously want to print a 0, and that takes care of the first bit. The second thing we can do here is we can save this as a variable, and because it's 8 bits in size, we would want to save it as a character. Now keep in mind, you can save any binary value as a character. It doesn't have to be a literal character like an A. So we can say char bitmask equals, and there you go, and then we can change this to bitmask. Now, one more thing here is, remember that whenever you are working with data, there are two ways you can think of the data. You can think of it as being signed or unsigned. Remember, there's the signed bit or there isn't the signed bit. Now here we're not treating bitmask as a literal character. We're going to be treating it as a binary value that we're going to want to perform mathematical operations on in order to, in effect, move this bit around. We want to move the bit from here to here to here and so on. So in order to be able to do that correctly, we need to say that this is unsigned. You'll see why in a minute. Now, we're just about ready to begin. If we run this program in its current form, you'll see that it accurately prints the first bit. So how do we make it print all 8? Well, we just have to create a loop here. Let's create a looping variable. And now we'll create a for loop. We'll start I at 0. As long as I is less than 8, this will execute, which means it will happen 8 times. So each time this executes, we're going to evaluate the character and the bitmask, which means that at the end of the loop we need to change the bitmask to, in effect, move the bit 1 over. It's going to start here, then we want it here, and so on. How do we do that? If we imagine that we have this binary value, which is 8, and we want to move the bit over, notice that we get 4. If we move it over again, we get 2. So the way that you move the bit is simply to divide by 2. And this is why unsigned is important, because if one of those bits is being treated not as a value but as an indicator of positive or negative numbers, then we won't get the result we want. So by setting it as an unsigned char, we're saying treat this entire 8-bit value as a single number, in effect, that can be manipulated using mathematical operations without any concern about positive and negative numbers. So we're going to start with the bit mask looking like this, then we're going to go through the loop, and at the very end we're going to change the bit mask to set it equal to whatever it was divided by 2. And that's it. Now if we run the program, you will see that we correctly print the binary value for the lowercase letter a. But there's one problem. How do I get that space in between? One very easy way to do that is just to have an if statement here that says if I is exactly equal to 4, we can print a space. Now let's see if I set that correctly. No, one less if it's equal to 3 because we're starting at 0. So there you go. And now I have my space. Now let's make this a little bit more interesting. Let's take this entire operation and turn it into a function that can print a byte in binary. So we're going to create a function. We'll say that it returns an integer. Really doesn't matter what it returns right now, but we'll call it print char. And what it will receive is a character that we will call, we should call it exactly what we had here. We'll call it mychar. And then let's go ahead and write out the actual function. I'll just copy and paste this to make sure that I type it exactly as I had it. And now we will take all of this and simply move it into our function. And at the end of the function we'll return a 1. Because we say that it needs to return an integer, so we should return an integer. Alright, so here we're setting our bit mask. We're going through the entire character and we're printing it. Let's go ahead and test that out. So, and of course we need our looping variable too, because we use that here. So now let's go ahead and just try print char and the lowercase letter a and see what happens. You'll see that it works just fine. Now let's try a capital B. And same thing, you can notice that the third bit is off because it's a capital letter, and 2 because A is 1 and B is 2. Now what if we wanted to print something longer than that? Well, let's say we wanted to print hello. We could just do it like this. E-L-L-O. Now, because each of our sequence of 8 bits run into each other, we can make this a little cleaner by saying that at the end of our function, before we exit, we can print F, a space, and a colon, just to make it more readable, and then we'll have something that looks like this. And now you can really clearly see the individual bytes as they are actually stored in memory. Now, if we want, we can actually do this with a string of text. Let's create a string literal and set it to hello. And then what we can do is create a for loop. So let's create another looping variable. Let's create our for loop. We're going to be doing 5 characters here. And what we'll do is this. We will print char whatever is at the memory address of the pointer string. Then we will increment string so that we're looking at the next character. So if we try that, the result is, and again we get H-E-L-L-O. Now remember that inside of a for loop you can have more than one expression here, so we can put the string plus plus here too, because that occurs every time the for loop executes and we have exactly the same thing. Now what if we wanted to have a string of any length? It didn't necessarily have to be 5 characters, but maybe it could be something like this. How could we do it then? Well, we need to have a way of specifying when to stop. A good way to do that is to use a while loop and remember the null operator. Remember, this string is going to end with a null character. I meant character, not operator. And so we can say this: while what is at the memory address string is not equal to null, then we can go ahead and print the character of what is at the string. And now we can just simply increment the string at the end of the while loop. And here we don't need a looping variable. So if we try this, you'll see that we're printing every character all the way to the end. Let's set the string of text to 1, 2, 3, 4. And you'll notice that each byte is printing in such a way that remember, all the numbers start with 0011, and then the 4 bits on the right will determine exactly what number it is. So 1, 2, 3, 4. There you go. So notice how much easier it is when we can incorporate this into for loops and use the else keyword in the if statements. So I hope you enjoyed this lesson, and if you have any questions, feel free to ask them.